Hello students, today we learn about the hydrodynamic lubricated bearings. In hydrodynamic lubricated bearings, there is a thick film of lubricant between the journal and the bearing. If we see this diagram, this portion is called as bearing, this is called as journal. Then in between journal and bearing, the gap is available. So in that gap, here we provide the thick film of lubricating oil. When a bearing is supplied with a sufficient lubricant, a pressure is built up in the clearance space. When the journal is rotating about an axis that is eccentric with the bearing axis, the load can be supported by this fluid pressure without any actual contact between the journal and the bearing. Again, if we look this diagram, as the journal starts to move, then in this oil the pressure gets built up, and due to this pressure the load, this bearing can take the load. If we see the principles of hydrodynamic lubrication in journal bearings, there are three different cases. We discuss that cases one by one. If we see, this is case A. If shaft or journal is at rest, this journal is also called as shaft. If that journal is at rest, if we observe this diagram, then here we give some names. This point is point A. When the journal is stationary, then when the journal is at stationary condition, then the direct contact takes place between the journal and bearing at location A. Here eccentric distance is shown with symbol E, that is distance between center of bearing, that is O, to the O dash, that is center of journal. This figure A shows the journal at rest. In this case, journal sinks to the clearance space under the action of load W. That is mean by the journal comes in direct contact with this bearing at location A. No gap is present between this journal and bearing at location A. So we say that the surfaces of the journal and the bearing touch during the rest. If we see the second case, that is case B, journal starts to rotate, or this case is also called as slow speed case. In this case, as the journal starts to move, then this journal tries to move in different direction around this bearing. When the journal rotates slowly in the clockwise direction, as shown in this figure B, the point of contact will move to B. In first case, the point of contact is at A, and here as the journal starts to move slowly, then this point of contact gets shifted from point A to point B. At this location, the journal comes in contact with the bearing, so that the angle AOB is the angle of sliding friction, of the surfaces in contact at B. This angle AOB is called as angle of sliding friction of the surfaces in contact at B. If we see the next, that is in absence of lubricant, there will be dry metal to metal friction. If the lubricant is present in the clearance space of the bearing and journal, then a thin absorbed film of the lubricant may partly separate the surface, but a continuous fluid film completely separating the surfaces will not exist because of slow speed. As speed is slow, so the lubricating film is absent at location B and direct contact takes place in journal and bearing in this case also. If we see the case C, this case is somewhat different as compared to A and B. Here the speed is high, so this type is journal rotates at high speed. In this diagram, this is journal which is rotate in clockwise direction. O is the center point of this bearing, O dash is the center point of journal. If we see the gap in between journal and bearing, so throughout gap is there. When a speed of journal is increased, a continuous fluid film is established as shown in figure C. The center of the journal has moved so that the minimum film thickness is at C. If we see here, this is the minimum film thickness, and here this is the maximum film thickness. It may be noted that from D to C, if we noted that from this D point to C point, in the direction of motion, the film is continuously narrowing. In the direction of rotation, this film is continuously narrowing. And hence is a converging film. This film is called as converging film. So in this case, here the shape gets decreased like this. Here the space is maximum. If we move towards the point C, the space gets reduced. And if we see the effect of the pressure, then we see the second diagram. So if we consider this is the shaft, this is the bearing, and force pressure is acting in this direction. If we see the second view of same diagram, then this is the bearing, this is the journal, and as the space gets reduced, then here the pressure gets increases. So here if we observe here, the gap is more, and as we move towards in the, here the gap is less. So where the gap is maximum, then pressure is less, and as the gap is reduced, then pressure gets increases. This is the concept in this high speed rotating journal bearings. Now if we see the figure number C, it shows that